The mystery. We live inside. Imagine this. You're floating somewhere in deep space, silent, alone, and stretching before you, an endless sea of stars, swirls of light, clusters of gas, rivers of cosmic dust, all spiraling around a glowing core. That is the Milky Way. And here's the twist. You live inside it. But despite calling it home, we barely understand it. Not just the wild edges of it, but even the basics. How many stars are truly out there? Does our galaxy have 2 spiral arms? Or 4? You'd think we'd know the structure of the house we live in, right? But no. Looking out of your window to the house across the street is easy. But trying to look at your own house from inside the living room? That's a different story. Welcome to the mystery we live inside. In this documentary-style deep dive, we'll explore how one extraordinary space telescope, Gaia, has transformed our understanding of the Milky Way. And more shockingly, how it revealed that our galaxy has a secret appetite, an ancient habit of devouring other galaxies. We often talk about space as the final frontier. But when it comes to the Milky Way, even the first frontier still holds mystery. You see, despite all the technology, all the telescopes, and all the satellites, we're still uncertain about some of the most fundamental facts of our galaxy, like its shape, or size, or even its true number of stars. Some estimates suggest 100 billion stars. Others, 400 billion. It depends on the methods used and the assumptions behind them. And then there's the question of its structure. For the past 2 decades, scientists have gone back and forth. Does the Milky Way have 2 spiral arms or 4? The current leaning is 4, but we're still not entirely sure. Why all this uncertainty? It's not because we're not looking. It's because we're inside it. Trying to map the Milky Way is like standing in the middle of Times Square and trying to draw the skyline of New York, blindfolded. Gas clouds, dust, and star fields block our view. And near the galactic core, it gets even worse, creating an area astronomers ominously call the zone of avoidance. Light can't easily pass through it. It's thick, dense, chaotic. The only way through? Use something beyond visible light, like X-rays, infrared, or radio waves. So, how do we even begin to unravel this mystery? Enter Gaia. Gaia, the galaxy mapper. So how do you uncover the shape of something you live inside? How do you map a galaxy when the stars, the dust, the gas, all cloud your vision from every angle? The answer? You don't try to see the whole thing at once. You measure everything, one star at a time. That's the genius behind Gaia, the European Space Agency's boldest galactic explorer. Launched in 2013, Gaia's mission wasn't to snap pretty pictures or chase exoplanets. It was to do something much harder, build the most precise 3D map of our galaxy ever attempted. And to do that, Gaia needed to measure the exact positions, brightness, movement, and distances of stars. Billions of them. Over 10 years, Gaia performed over 3 trillion measurements, tracking more than 2 billion stars across the sky. But how does it measure distance in the vast emptiness of space? Well, Gaia didn't invent a new method. It perfected a centuries-old one: parallax. hold your finger in front of your face. Close one eye, now the other. Notice how your finger seems to jump? That's parallax. It's the way nearby objects appear to shift more than distant ones when viewed from different angles. Now, scale that up. Instead of the few centimeters between your eyes, imagine Gaia using the width of Earth's orbit around the Sun as its viewing baseline. Every 6 months, as Earth swings to the opposite side of its orbit, Gaia takes a new measurement. That tiny shift in a star's position, barely a fraction of a pixel, can tell us how far away it truly is. And over a decade of continuous observation, Gaia can chart the proper motion of stars, how they actually move through the galaxy over time. This motion reveals not just distance, but direction and speed. And it turns Gaia into something far more powerful than a telescope. It becomes a time machine, showing us how stars have moved in the past, and predicting where they'll go millions of years into the future. But Gaia's power isn't limited to position alone. Its onboard instruments also gather detailed spectral data, information about each star's light. From that light, scientists can determine temperature, chemical composition, stellar mass, even clues about how and when a star was born. Gaia doesn't use just one telescope. It has two, angled precisely to collect light from different directions, both feeding into a billion-pixel camera, the most accurate camera ever flown in space. And with this setup, Gaia has done something no other mission has achieved. It created a dynamic, ever-evolving model of our galaxy in motion. Over time, this map becomes richer, sharper, and more alive, like watching a living organism breathe and shift. But then something strange emerged. Among the billions of stars Gaia tracked, scientists noticed something odd. A group of stars, about 30,000 of them, was behaving differently. While most stars rotated with the flow of the Milky Way's spiral, this peculiar group was moving the other way, like salmon swimming upstream, rebellious, misplaced, out of sync. Where did they come from? That question would lead to one of Gaia's most shocking revelations. Galactic cannibalism, the Milky Way's secret appetite. It began with a question, simple, quiet, and unexpected. A group of stars drifting through space were moving in a way they shouldn't have been. Most stars in the Milky Way follow the natural spin of the galaxy, like leaves caught in a spiral stream. But these 30,000 stars were going the wrong way. Not just different, opposite. At first glance, it could have been a glitch, an instrument error, a quirk in the data. But Gaia doesn't lie. The more the team examined the numbers, the clearer it became. This wasn't a mistake. It was a message. These stars weren't just moving strangely. They looked strange too. Slightly different colors, unfamiliar brightness levels, odd chemical compositions that didn't match the local stellar population. It was as if they were guests at a party where they didn't quite fit in. And like guests, the question followed. Where did they come from? To find the answer, scientists did something remarkable. Using Gaia's detailed data about how these stars moved across the sky, not just their positions, but their velocities and accelerations, they ran time backward. Like rewinding a video frame by frame, they reconstructed the motions of these celestial bodies over billions of years. What they uncovered was a story billions of years in the making. Roughly 8 to 11 billion years ago, When the Milky Way was still young and still forming its identity, another galaxy approached. It wasn't large, just a dwarf by comparison. But it carried its own stars, its own gravity, and its own destiny. The approach wasn't sudden. There was no violent crash or dramatic explosion. It was slow, methodical. A gravitational embrace that began subtly until the smaller galaxy could no longer escape. Our Milky Way's massive pull drew it closer and closer until its stars were caught in the grip of a force too great to resist. Over time, that galaxy was dismantled. Not instantly, but gradually, as if the Milky Way were savoring its meal. Star by star, piece by piece, the smaller galaxy was shredded and absorbed. Its core dissolved, its stars flung outward, scattered across their new home like seeds in a wind. Those stars, those 30,000 rebellious ones Gaia had flagged, were the remains of that galaxy. Ghosts, drifting through unfamiliar territory. They still moved to the rhythm of the galaxy they came from, not yet tuned to the music of their new surroundings. Scientists named the lost galaxy Gaia Enceladus, and for a time, its stellar remnants retained their distinct identity, like echoes that refused to fade. The story, once discovered, felt both epic and deeply human. A foreign object arrives. It is changed by its environment. It disappears. But parts of it remain, scattered and changed, still carrying memories of where it came from. It's a story of collision, transformation, and quiet survival. But the tale doesn't end there. As researchers followed Gaia's ever-deepening archive of stellar motion, they began to notice more anomalies, more stars that didn't behave the way they should, more whispers in the starlight, and soon a pattern began to emerge. Gaia Enceladus was not a singular event. The Milky Way, it seemed, had done this before, more than once. Evidence pointed to another victim, a small galaxy scientists nicknamed Sequoia, then another, and another. What once seemed like an isolated case was now a trend, a pattern of cosmic consumption. The Milky Way, elegant and beautiful from afar, was revealing a far more predatory history up close. Our galaxy, it turned out, had grown not just by collecting dust and forming stars, but by devouring smaller galaxies, slowly incorporating their stars into its structure like trophies. It was a galactic cannibal, and the most dramatic chapter in that long feast might still be unfolding. A dwarf galaxy known as Sagittarius has been colliding with the Milky Way repeatedly, at least 3 known times over the last 5 billion years. And it's not done yet. Right now, even as you read this, Sagittarius is being torn apart once again. Its stars, already stretched into tidal streams, are being pulled into the Milky Way's gravitational well, slowly, silently, inevitably. One day, Sagittarius will be gone. Another memory folded into the spiral arms, another chapter in the history of our galaxy's appetite. But perhaps the most poetic revelation of all came when scientists began comparing timelines. As it turns out, one of Sagittarius's previous collisions with the Milky Way happened at a particularly meaningful moment, around the time our own sun was born. It's a hypothesis, still debated, but grounded in good evidence, that the shockwaves and gravitational chaos stirred up by that ancient galactic collision may have compressed nearby clouds of gas, triggering the formation of new stars. Among them was a young yellow dwarf star, tucked into the edge of a spiral arm. We know it now as the Sun. If that theory holds, then our very existence may be a consequence of cosmic violence, a star born in the wreckage of a galactic meal, a planet formed from the ashes of two merging worlds, and life, our life, emerging in the quiet aftermath of a collision. It's a staggering thought, that we are not just residents of the Milky Way, but products of its hunger. So the next time you look at the stars, remember that not all of them were born here. Some are immigrants, refugees, survivors of long-lost galaxies, flung across the sky by ancient forces. Their light carries memories of where they came from, and Gaia, our patient cartographer, has helped us read their stories for the very first time. These stars remind us that the universe is not static. It's shaped by encounters, collisions, and change, just like us. Gaia's hidden discoveries. Secrets among the stars. Even after a decade of observation and over 3 trillion data points, Gaia's work continued to yield new surprises. Quiet revelations tucked away in the fine print of starlight. No one expected the mission to become a storyteller. Its purpose was mathematical, its design logical, and its work relentless. But as the data poured in and astronomers began to piece together the patterns, Gaia was revealing more than stellar positions. It was pulling back the curtain on the secret machinery of our galaxy, and, unexpectedly, far beyond it. Some of these stories were written in motion. With enough time and enough precision, Gaia could watch the sky shift. Stars that had once seemed frozen were now seen drifting, some slow and steady, others in subtle arcs or curious loops. These motions, too small for the human eye, began to tell us who was alone and who was bound to someone else. Gaia was catching relationships, hidden companions circling each other, their orbits betraying secrets even light could not reveal. And then there were the shadows, not the kind cast by objects, but the invisible distortions written into the behavior of light itself. Sometimes, Gaia would see a star tugged in a strange direction, an invisible hand pulling ever so slightly. Those tiny wobbles hinted at massive companions, invisible to the eye, but massive enough to twist the light. Some of these were ordinary binaries. Others, perhaps, were something else entirely. Astronomers dug deeper, cross-checking the motions Gaia captured with models and simulations. They began to suspect something heavier. In a few rare cases, the data refused to add up unless you accounted for a companion that swallowed all light. One so dense, so compact, that it betrayed itself only through gravity. The whispers grew louder. Could Gaia have found black holes? Not just any, but massive ones, dark giants drifting silently just a few thousand light-years from Earth? It wasn't supposed to. Gaia wasn't designed for that. But the data didn't care. It told its truth anyway. Beyond the Milky Way's spiral arms, Gaia's gaze extended into the deeper dark, where flickers of ancient light crossed billions of years to reach us. It began mapping objects that didn't move at all, not from our perspective, at least. These were the anchors of the sky, quasars, so distant that their light began its journey before our solar system formed. To Gaia, they were stable lighthouses, perfect for reference points. But to astronomers, they were also a window into the universe's infancy. And Gaia found them by the hundreds of thousands. What began as a galactic survey was now brushing the edges of cosmology. It was touching the past not through imagination, but through measurement, recording echoes from a younger universe. Closer to home, Gaia was tracking smaller, faster things, objects within our own solar system, some known, others never before identified. It spotted patterns in their orbits, tiny irregularities that hinted at interactions. It noticed which objects moved in concert, which seemed to wobble, and which appeared to have smaller companions trailing behind. And from these motions, the shapes of moons and systems began to emerge. Gaia was revealing not just stars, but families of rocks and ice, huddled together in gravitational intimacy. It also reached into the future. With so many stars observed for so long, Gaia could extrapolate their paths forward, projecting their movements millions of years ahead. What looked like a scattered sky began to reveal a deeper rhythm. Some stars diverged, yes, but others circled back, drawn by invisible tides. Waves of density seemed to ripple across the Milky Way's disk, sculpting the spiral arms themselves. For the first time, we could witness the choreography of our galaxy in motion. Not static snapshots, but a living, breathing structure. But the most powerful aspect of Gaia's work wasn't what it found. It was what it empowered others to discover. By releasing its data to the public, Gaia became a gift to the scientific community. Universities, observatories, and amateur astronomers alike were handed the keys to a cosmic archive unlike any before it. New research papers sprang up by the thousands, each one a doorway into a different corner of the universe. It was no longer just about stars, it was about movement, temperature, evolution, birth, and death. And in the quiet corners of those discoveries were hints of more to come. Patterns just now taking shape, questions still waiting for clarity, signals not yet confirmed. The mission was not merely a telescope, it was a foundation, a digital galaxy, preserved and waiting for this generation and the next. Even now, the story is still unfolding. Gaia's next major data release, its fourth, is set to unveil another wave of revelations. It will include hundreds of terabytes of observations made sharper by time and perspective. Then will come the fifth and final, containing the complete 10-year chronicle of the mission in exquisite, unfiltered detail. It's hard to overstate what's been made possible. A sky once painted in myth and mystery is now mapped with extraordinary precision. We no longer just see the stars. We feel their motion. We hear their history in the way they drift. We understand their connections. Gaia taught us that the universe doesn't stand still. It pulses, it breathes, it remembers. And somewhere, hidden in that ever-expanding sea of data, are still more secrets, waiting to be found. The end of Gaia and the future beyond. Every mission, no matter how visionary, eventually finds its silence. And after more than a decade of peering into the night, measuring the breadth of stars and the drift of galaxies, Gaia has reached that moment. The spacecraft that once mapped the sky with unrivaled precision has taken its final look. Its fuel, small, steady puffs of cold gas, has run dry. That delicate balance it held for years, stationed far from Earth at the second Lagrange point, can no longer be sustained. On a quiet day in January 2025, Gaia recorded its last observation. And by March, it will begin the slow process of shutting down, folding its gaze inward one last time, and fading into the stillness of space. But endings are not always quiet. Sometimes they echo. Gaia's legacy is not just in what it did, but in how completely it changed the way we see the cosmos. It was never built to dazzle the public with vivid images or to chase breaking news headlines. It wasn't fast, and it wasn't flashy. Instead, it was careful, precise, patient. For over 10 years, Gaia watched the heavens shift, one star at a time, one observation at a time, until the sky itself began to move in our minds. The map it created is not a snapshot, but a living document, a record of light and time that will guide astronomy for generations to come. It revealed structures we never knew were there, motions we couldn't see before. It caught stars as they curved across the galaxy, trailed by companions, or moved against the flow like ancient rebels from a forgotten time. It turned statistics into stories, and stars into messengers. It showed that the sky is not static, but alive with hidden rhythms. In the light, Gaia measured were whispers of long-lost galaxies, those that once collided with our own and vanished, leaving only scattered stars as evidence. It found echoes of violence in the graceful spin of our spiral arms. It traced paths that hinted at histories we never imagined, and hinted at futures not yet written. From the quiet wobble of an asteroid to the ghostly tug of a dark companion, Gaia's instruments turned silence into signal. And it did all this without ever leaving the solar system. But Gaia's greatest gift may be the questions it leaves behind. For in answering what we thought we wanted to know, it revealed the depth of what we still don't. It opened a door not just to knowledge, but to wonder. And behind that door lies the future. Even as Gaia powers down, the dream it set in motion has already begun to evolve. A new mission, tentatively called Gaia-N, is being imagined. It would inherit Gaia's vision, but extend it into new realms. Where Gaia was limited by visible light, Gaia-N would see in the infrared, slipping past the dust that once blinded us, opening windows Gaia could only hint at. It would trace the outlines of stars hidden behind veils of gas, reach deeper into the structure of our galaxy, and perhaps glimpse the first moments of starlight ever born. This next-generation telescope is still in the realm of planning. If approved, it may not fly for another 2 decades. But its foundation, every calculation, every coordinate, every unexpected discovery, will be Gaia's. The data we already have will guide its path. What Gaia-N sees will be rooted in what Gaia made visible. That's the nature of legacy. It doesn't end. It unfolds. So what do we take from all of this? What does it mean that one spacecraft, drifting in silence far beyond the moon, could transform the way we understand our place in the universe? It means that scale doesn't define significance. Gaia didn't need to go far to see deep. It didn't need to shout to be heard. It worked in the margins, in the micromotions of stars, and the delicate dance of data. And from that quiet, it taught us that our galaxy is more than a place. It is a story, a living record of birth, collision, migration, and memory. And we are part of that story. The atoms in our bodies were forged in the stars Gaia tracked. Our planet moves through the same gravitational currents Gaia mapped. We are shaped by the forces it revealed. The more we learn about the stars, the more we learn about ourselves. Tonight, if you look up at the night sky, try to see it not as a pattern of dots, but as a flowing sea. Behind each pinpoint of light is a trail, a path, a motion. Some of those stars may have come from other galaxies. Some may be moving toward you. Some, perhaps, will one day pass near our sun. And some are already long gone, their light still crossing the cosmos toward us. Gaia saw them all, not in color or glory, but in truth. It watched quietly. It measured faithfully. And in doing so, it gave us not just data, but perspective. So this is not a farewell. It's a thank you to a machine that never spoke, yet told the greatest story we've ever known. Thank you, Gaia. And to whatever comes next, we'll be watching.